Yay, 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 math. Yay, math, 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 yay, Yay, math!
We're actually gonna. Wow, look at the pretty board! It's the season finale!
See you next time.
Okay, so we're gonna go out with the huge bang, people. Trigonometry. We're gonna do a lot today, so let's just jump right in it. Okay, there's a lot to do. Some you've seen, some you haven't. Alright, it's all about trigonometry. There's this one amazing poster I saw. It was in black and white and have a bridge collapsing, all right? And on the bottom it said, engineer who skipped just one trigonometry assignment. Okay? So I thought that was funny. Trigonometry is the relationships of angles and the right triangles or triangles that they're in. Let's talk about it. Here we go.
In other words, irrelevant.
In other words, entirely relevant. People think it's not. But architecture, how relevant is architecture?
I love me personally or to the world?
To you personally.
Not at all.
You been to Barcelona?
Yeah.
Antonio Gaudi? Beautiful. All architecture, all trig. So here we go. This is a right triangle, as you can tell. And we are going to create some angle relationships. Let's make some examples here. Let's make this 40 degrees. And I'm going to make it
Big.
40, and we'll make this 12x, y. Okay, so normally, if you're trying to solve for x or y, you would use Pythagorean theorem because you would be given x or y. Right?
Is this a right triangle?
This is a right triangle. Thank you, I did erase that. So, if you're given x, for example, you can solve for y using Pythagorean theorem. The other way around. So now we're going to use trigonometry because we don't have enough sides. So yeah, we've heard SOH CAH TOA a couple times. Let's define it. SOH CAH TOA. It sounds kind of Native American. Here's how it goes. S-O-H-C-A-H-T-O-A. SOH CAH TOA. Okay, here it goes. Real quick. Someone volunteer. S.
Side.
Sine. Sine is what?
Overall.
No, what is it?
Opposite and
Opposite.
opposite. Sorry.
Over.
Opposite and hypothesis.
No. Close. Yeah. Opposite over hypotenuse. So it would be like this. Sine equals opposite over hypotenuse. Sine of an angle, you can say. Sine of an angle. So the angles that we're going to be using and is classically used within trigonometry is this symbol here. It's called theta. Theta. So that's the angle. Sine of an angle is opposite over hypotenuse. Cosine, C. Cosine of any angle equals what? Adjacent side. We'll talk about what that means. We'll talk about what that means. Adjacent over hypotenuse. Yes, sir?
What's the circle thing with the line?
It's called theta. It's an angle. So this right now we'll call theta, 40, let's say. Okay, extend. And T.
Tangent.
Tangent. My dad, when he was teaching me this when I was your age, he would call tangent tang. And he would call this cosine. Cosine, because he couldn't say cosine very, you know.
Yes! And that was an upbeat family memory.
Your dad's gonna watch this.
Yeah, why not? So tang is what?
Tangent.
Tangent is what? Opposite over
adjacent.
All right, good. Good job. So, we start at an angle, 40 degrees. let's define what, now stand in the way here. What is the opposite side to 40 degrees?
X.
X is correct. What is the adjacent side to 40?
Y.
Y is adjacent. Adjacent means next to. So that's Y is the adjacent side. And what is the hypotenuse?
12.
12. Hypotenuse is always opposite the right angle. What's this angle going to be?
You can
Okay,
figure it
40
out.
plus 90.
Yeah, 40 plus 90, 130. All triangles add up to 180, so this is going to be 50. So if we're talking about this angle, what is opposite to 50?
Y.
Y. What is adjacent to 50?
X.
What is the hypotenuse?
12.
12. Very good. So let's pick one of these trig functions and solve. You please have your calculators handy if you don't already.
Sine.
So let's do sine.
Hold on.
Let's do sine
For which one?
for
For 40.
40. Yeah. Go. Just watch the door. Okay, so here we go. Sine.
Do you do sine and then just
You always do sine, cosine, tangent of
No,
angles.
I mean, do you do sine?
Of 40. Yeah, so sine of 40 equals. Okay, classically, this should be y because it's an up and down thing. You'll see why soon enough. But for this purpose, it doesn't even matter. It's okay. So sine of 40 equals what over what?
Point.
Yeah, we're going to get to that. But first,
X over
x over
12.
12. Okay, cross multiply, x equals what times what? If you cross multiply.
12 times sine of 40.
Yeah, that's right. 12 sine 40. Okay. You plug that in the calculator, and you have what x equals.
You can't just
Yes.
write sine.
How do we get that one more time?
Sure. Are you cool with sine 40 degrees equals x over 12?
You can't just write sine 40.
Sine 40 is correct.
No, and like you get this. That's wrong.
Right. Sine 40 we got is 0.6428.
But then you multiply
But then you multiply that by 12.
So it's 7.7.
Yeah, multiply that by 12.
I got 8.9.
Why?
Cross
Yeah, so
multiply.
did I.
Cross multiply. X times 1 is x.
7.7.
Sine 40 times 12 is
Yeah.
12 sine 40. Put this in calculator. 12 times the sine of 40. What do we get?
7.71.
7.71.
Oh, I got 8.9.
Are people in radian mode? If you're using graphing calculator, many people are.
Yeah.
Hit mode. And you'll see that you're in radians possibly. It's the second or third one down. Switch it to degrees. Switch it to degrees. We're going to go back to radians later today. All right, so now try it. Make sure when you're in mode, you're in degree mode. All right?
There you go.
So bad.
So it's 7.7.
7.71.
7.71. Okay.
Wait,
7.71.
we still got that.
Okay, good.
Yeah, let's go.
All right, let's set up the equation for solving for y now. There is a multiple variety of ways to do this, but what would be the most straightforward to solve for y? Anyone?
Obviously.
Wait,
Yes, question.
time.
Nice and loud.
Wait, what's X?
X equals 7.71.
Oh, no.
You're fired.
It's supposed to be in radians, right?
No, degrees.
Oh.
Degrees, 40 is in degrees. Okay, so let's set up to solve for y. What would be the most straightforward way to solve for y?
Tang.
Tangent. What tangent would be what over what then?
It would be x.
X over y.
Y.
Tangent equals what over what?
Opposite over edges.
So tangent of 40 would be,
Oh, at 40
yeah,
is x.
yeah, x over y. That's right.
Oh.
Okay?
Sorry, I see you for a second.
Okay. So I hit stop. Okay. So we're going to resume by solving for y. The question is, we just heard before. Your question was,
How do you know which one to use, and when you do,
yeah.
which one goes on top of the
You have to figure out what you have. All right? What do you have?
Yeah.
So when we're looking at solving for y, we have 40 degrees and we have 12. So which one of these trig functions will involve y and what we have? Because that'll help us. We want to use what we have. So which one of these functions, when we're talking about 40, uses the adjacent side and the hypotenuse?
Cosine?
Cosine. Yeah, cosine. Watch what happens. Can you set it up? Cosine of 40.
Okay, cosine of 40 equals adjacent y over 12.
That's right. Now notice, y here is the only variable, so we can solve for it, correct? So we can solve for this now. If you decide to do tangent, you would do tangent of 40 equals, check it out, opposite over adjacent, you would do x over y. That would give you two variables. You can't solve for anything unless we use the x we already got. Okay? So you're allowed to do that.
Why are we using 40 instead of 90 or 50?
Okay, good question. Whenever you're doing these trig functions, it's always regarding the other angles. Yeah, you're not, the 90 is left alone. 90 sets up the right triangle, but the trig functions occur with the angles that are next to it. Right? You can do trig functions on either one of these. All right, let's set this up. Solving by cross multiply, y equals cosine of 40 times 12. What's that? What's cosine of 40?
9.1.
9.19? Works for me. All right.
Was this just another step we could have done this problem, or is this continuing?
This is two problems, the x problem and the y problem.
Oh, but you need to solve for both.
Solve for both in two different equations. Yeah. Okay, so let's take this off.
No.
Right? Faster. Sorry. I'll check with you before. My bad. All right, so who can call out the battle cry for trigonometry?
SOH CAH TOA.
Very good.
What?
Can you repeat that? Geronimo.
There it is right there. It's always good to write that at the top of your test, quizzes, homework. Write it right there. Remind yourself. Okay, solve the following triangle, please. $16 there. Z degrees there. X, Y, 14.
Is it right?
And it's a right triangle, yes. All these are right. Yes?
Will they always be right triangles? Or?
Yes, we're going to be working with right triangles. That's how these trig functions work. So while you're getting into that question,
Solve for x and y.
solve for x, y, and z.
Okay, see, we already know.
Z you already know, correct. Okay, volunteer to set up an equation.
I can try.
Oh,
Want to try it?
Sure.
Okay, try it. We'll get more. Yeah, tell them what to write. Tell them what to write. Yeah.
Okay. I want to do the second one, right?
The sign one?
Yeah.
There's multiple ways to do this. So whatever works, we'll be fine. Try it.
Okay. 16.
Sine.
Sine
What?
16.
Sine 16. Good. Yeah.
X over 14
Equals
equals x over 14.
x over 14. Questions? This is correct. How can someone else explain why this works?
There's only one variable.
There's one variable, so we can solve. But why does it work like this? Yes.
Because you look at the triangle and you see that the angle across from, opposite of x is 16, so you're
Right.
trying to find sine of 16.
Right.
And
Opposite
then
of
it's
16 is x.
opposite over hypotenuse.
Right.
So.
Opposite of 16 is x over hypotenuse, which we know is 14. Cross multiply. Cross multiply.
X equals
X equals.
14 sine 16.
All right. Plug that in the calculator. We're done.
8.86.
8.86.
3.8.
3.86. Are these numbers realistic? Yeah, it works. This is a small angle, so opposite it must be a small number. Has to be less than the hypotenuse. So yeah. So 3.86. Y equals, or excuse me, let's set up an equation with y.
Cosine 16.
Cosine. Oops. Cosine of 16 equals
Equals x over 14. Oh, y over 14.
y over 14.
Yeah. Any possible.
Then it's 14 cos.
Y
Yeah.
equals
Y equals 14
cosine.
cosine of 16.
Is 13.457.
13.46. Very good, very good. Now, if we did this a variety of ways, we would get the same thing.
Did you ever use 90 for them?
No, we shouldn't do sine, cosine, or tangent of the 90. Only of the other angles. Now, check it out. There's so many ways to check your work. Y here is 13.46, and this is 3.86. Volunteer to check Pythagorean theorem if it works. Just do it right on the calculator,
Can you
please.
do the tangent?
See if it works. We could do tangent, but we don't really need to. See if Pythagorean theorem works. It has to. This squared plus this squared should equal 14 squared.
What? 481.33.
Yeah, it's 196.07.
196.07. So yeah, 14 squared is 196.
Yeah.
Right.
I
Okay.
still moved it.
Good.
Whoa, wait. 13
.46.
We check this with Pythagorean theorem.
plus 3.86
6 squared
plus.
equals.
No, equals.
So just hit enter on that.
Yeah.
196, right? And then notice, yeah, it's decimal, so it's not going to be exact. All right, so that's half the lesson. Yes, sir.
All right.
Oh, you got it? Okay, good. Okay, here we go. Oh, we didn't solve for the other angle, z. So it's 90 minus 16? 74, good. So z was 74. Good catches. All right, here we go. Okay. Now, what's the angle?
X.
How many degrees is this?
X degrees.
Okay, but we don't. How do we solve it? Any idea?
The
Sine.
sine
Okay,
of
so
x equals 8 over 15.
all right, go ahead. Stop right there. That's really good. That's really good. So we're gonna set up the equation. Sine of theta. Start saying the angle. Sine of theta equals 8 over 15.
And then
Okay,
Where's theta?
right in here. Yeah, we are going to solve this in the calculator. So yeah, looks like you've had exposure. What do we do?
you do the, what's it called, arc sine? The,
Arc sine or
arc
inverse
sine?
sine?
Or the one that says sine to the negative 1. I
Right.
think it press
So-
the button.
Because we have sine of this variable here, to release this variable from sine, what we do, what I like to do, is we take the inverse sine of both sides. So look at your calculator. Right above the sine button, in the second mode usually, is sine to the negative 1. That's called inverse sine, or arc sine. It's called one of those. So we take that to both sides.
But how do you put sine to the...
You'll see. So sine to the negative 1. So in other words, this angle equals
Sine to the negative 1.
8 over 15. So sine to the negative 1, say inverse sine.
Oh, there.
So hit second sine, which would be inverse sine,
32.23.
32.23. Does that sound realistic for degrees?
Yeah.
Yes.
Wait, can we... How do you get rid of the variable again? Oh, okay, never mind, got it.
Is it theta?
Never mind.
Oh, the sine?
So the inverse, those two cancel, so you have
Yes.
theta equals.
Yeah, theta equals inverse sine of 8 over 15 in the calculator. We got 30 what?
32.23.
32.23. And always, here, let me write it. Always ask yourself if the numbers are realistic. Don't fly blind, as I say. Right? 32.23, that makes sense for an angle, 30 degrees. If this thing became 90 something, it's wrong. because that's more than, it would be more than a obtuse angle, and we already have 90 here. If this became 0.7 something, that would be wrong. 0.7 doesn't make sense for an angle. That would be the smallest angle. It's less than a degree.
One more time. When do you do inverse?
Inverse sine is when you're looking for an angle. Inverse sine is when you're looking for an angle. Sine is when you're looking for a side. In the previous two problems we did.
So,
Yes, more.
sine is side. Sine is four-sided.
You always do sine of an angle, right? Sine of an angle. Remember last time we did sine of 40?
Right.
So it's always sine of an angle.
Right.
And it's inverse sine of sides.
So I have to do both sides, right?
But basically we look at this, we couldn't do anything with sine of an angle because we don't know the angle.
Right.
So we want to get rid of the sine by doing inverse sine to both sides.
Couldn't we?
So the inverse sine and the sine cancel out, and
Yeah.
it's like angle.
And you're left with inverse sine of 8 over 15. Couldn't we just what?
Instead of just doing the inverse, can't we just do Pythagorean theorem to find both sides?
We can find the side, but what would the angle be?
No, I know.
Right. Yeah, in this case, we don't need trig to get the third side. We can do Pythagorean. Seder? Okay. Here it comes. Okay, hold on to your ride. You still have energy? You still with me?
Woo!
All right. It's really, it's thick. It's thick. Okay, get ready to see something you've never seen before in your entire life.
Oh my god.
This is exciting for me. Here we go. Please draw a graph.
Wow.
Have you seen this before?
No.
What's a graph?
You guys are all
That's great.
stupid. It's really far into the year.
Great acting. Okay,
Graph?
so here's our starting point, this line, this x-axis. I know,
Line.
that's what's fun. Here's our starting point, this x-axis.
Starting.
If we went from the beginning all the way around here and ended, how many degrees did we go? 360. So good. 360 is all the way around.
Yes.
Okay. Now on, we are going to denote 360 degrees in radian mode. This is degrees. Radians is another form of angle measurement. It is equivalent to 2 pi. 2 pi. Okay. So if we start here and go all the way around and end, we just went 2 pi radians.
Okay.
Radians. How many degrees did we go?
360.
360. How many radians did we go?
2
pi. Okay. If we went half a revolution, how far did we go in degrees?
180.
180. How many degrees? And how many radians now?
1.
So that's right. So that's 180 equals pi.
My favorite food.
I'm glad. Okay. All right. So what about a quarter revolution? How far is that? How many degrees?
90.
Yeah, that's right. So this is 90 degrees. And half pi we call pi over 2. Pi over 2. So let's mark up your graph. Pi over 2. Pi. How many degrees is this?
Pi and 4.
Degrees first.
Oh.
What?
How many degrees? Starting from here, all the way.
195. That's really wrong.
So think of skating.
360.
270.
270, yeah.
270.
It's like 3/4 of a turn.
Yeah, 3/4 of a revolution. How many radians now? If you know that pi is
1.5.
pi and a half.
Pi and a half.
So we're going to call that 3 pi over 2. Those are the main intersections. We have pi over 2, pi, 3 pi over 2, and 2 pi.
2 pi or not 2 pi?
Yeah, or 0. So, would you agree that you would end up at the same place if you start at 0 and if you go 360, you're at the same
Yeah.
place.
Yeah.
And then at the same place that if you go 0 or 360 or 720,
No.
Yes.
Yeah.
right? 720
Whoa.
is 2 revolutions,
Yeah,
correct?
plus, yeah.
All right. So you're at the same place if you go 0 or 2 pi, or how many pi? 4 pi. Or how many after that? 6 and 8. That's right.
A lot
Okay.
of pi.
Questions on that?
I'd be happy.
Okay.
Really fast.
Yes.
The 3 is because it's 3 radians.
3 pi over 2 radians. You said pi and a half, right?
Right.
That's 3 over 2. 1 and a half.
Oh, 1.
1 and a half pi. Okay. So remember those major milestones. Now, quick review. $45,
90.
90. 45, 45, 90 triangle. Yeah, we're on it now.
Oh, jump on.
Who can fill in this triangle with the smallest possible numbers? Smallest
90.
possible numbers.
Root 3.
The root 3 stuff is for the 30, 60, 90 down here. So yeah, small.
Root 2, which is their
1, 2, 3.
partners.
Okay.
And x and 2x.
We're calling it root 2.
And x and x.
Not x
No,
next.
2x and
1 and 1. 1 and 1. 1.
oh yeah.
How do we know that?
This is on you now to memorize. And you will. And you will. 45, 45, 90 triangle. This is the smallest triangle that works. It's the most simplified. Can someone verify this with Pythagorean theorem verbally? Pythagorean theorem verbally? Want to try? So say it louder.
1 squared.
No, let it try. Let it try.
1 squared is gonna equal
2. 1 squared plus 1 squared is 2. Square root of 2 squared is 2.
Yeah.
All right. So
Let's write 2 instead of 2 squared.
You have to.
why don't you write 2 squared?
Or no, why don't you just write 2 instead of the square root of 2?
Because it's not 2. It's not 2. It's not 1, 1, 2. That wouldn't be a right triangle. Right triangle means Pythagorean theorem, correct? Right? Pythagorean theorem works for right triangle. Prove that this works. Let's go. A squared is
1,
1 plus this squared is
1.
2.
yeah. Okay, so 1 plus 1, so that's 2.
Yeah.
So the side. Hold on. So the sides, these two add up to 2, right?
Right.
So this should be this squared. What's this squared?
Oh.
2, right? So if 2 is here, it would be a 4, and that's incorrect. Okay. So that's one triangle. Now, let's
30,
do
60,
30, 60, 90. All right. Smallest possible numbers for the 30, 60, 90. Anyone? Okay, go ahead.
Right next, right there is 2x. Wait, no. Next to the 30 is rad 30.
Okay, so this is rad 3.
And then across from the 30 is x. 1, sorry. And the next one is 2.
Right, let's leave it as 2. That's good. Okay, remember, just quick brush up for the 30, 60, 90. The 30 side is the smallest side is 1. To get from the 30 side to the 60 side, we multiply the 30 side by square root of 3. Okay. And to get from the 30 side to the 90 side, we multiply by 2. Okay, you okay? Little injury? Yeah, these desks, they're not very soft. Okay.
You could say that twice.
So, I won't though. Now I'm so tempted to.
Yeah. It's thinking it.
Yeah. So these are the triangles to keep in mind. 30, 60, 90, 45, 45, 90.
All on that SAT.
Here it comes, all on the SAT. Good point. Now, in your graph, you can keep your same graph, or you can redraw one and draw one bigger. What's this one? How many radians?
Oh,
How many radians?
1/2 1/2 pi.
90 degrees.
Oh, 90 degrees is
Pi
pi half.
Pi over 2.
over 2.
I didn't understand.
Oh yeah.
How many radians here?
Pi.
Pi.
Over 3.
Oh.
And yes, you know this
Over
one.
3. Pi. Oh. 3 pi over 2. pi and a half.
Well, how are you graphing this?
I got it.
With the knowledge that 360 degrees is 2 pi, so 180 degrees must be 1 pi, and 90 degrees must be half a pi. That's how it goes. Half a pi, and 2 pi. Yeah. So
Wait, didn't. Is it opposite to this way?
we're going this way here. For now, we're going
Can you do like a
positive.
little area?
Yeah.
Oh, okay. So pi divided by.
Yeah.
Wow.
All right.
That's a perfect circle.
So it's. So all around is 2 pi.
All around's 2 pi.
Okay. Alright.
Okay, here we go.
Halfway through is pi. Okay.
Halfway through is pi. So if this is pi over 2 and this is 90 degrees, how many degrees and how many radians would half of this part be? How many degrees?
45.
Pi over 4, and how many degrees is this?
45.
45. Very good.
Pi over what?
This is pi over 4,
Yeah.
and which
Half
is
of that.
equivalent to, we're not going to do it yet, yeah, 45.
How did you get that? Because you're cutting 90.
Because you're cutting 90 in half, you get 45. And you're cutting pi over 2 in half, you're getting pi over 4. Okay? We're almost done with this. A few more minutes, 5 minutes. You're doing great. We're finishing with a bang here. Okay? I mean, seriously, we're packing in so much in one lesson. It's incredible. Here we go. Now we make a right triangle.
Oh boy.
Here is the advice every time. The angle will always be next to the x-axis. All right? The next problem, we're going to do an angle here. And the angle will be next to the x-axis. Or if we did an angle here, the angle would be here. All right? So keep that in mind. Question.
Pi over 4 is equal to 30 degrees?
45.
Okay.
Yeah.
If you half 90, you get 45. Right?
Okay.
If you half pi over 2, you get pi over 4. Right? Okay. If you have a follow-up question, feel free, please. Okay, so now, let's fill in this 45, 45, 90 triangle. What's this side? I'm in the way. What's this side?
1.
1. What's this side? 1. What's this side? Root 2. Okay. So, what if I were to say, this is great, we're so far. I can't believe how far we got in one day.
Alright.
What if I'm really impressed. What if I said, find the tangent of 45 degrees?
Okay.
Wait a minute.
I'm ready.
Tan 45.
You can, it's right here.
I'm prepared.
I'm in the way.
Adjacent.
Tangent is opposite over
You
adjacent.
can do 1 over 1.
So what is the tangent of 45?
1.
1.
1.
Can you repeat that? Sorry.
Sure. Tangent equals what over what?
1 over 1.
No, like in terms
Opposite over adjacent.
opposite
Yeah.
over adjacent. So here's 45. What's opposite the 45?
1.
1. What's adjacent to the 45? 1. So 1 over 1 is 1.
8.
Okay. So what's the tangent of pi over 4?
Pi.
What? Pi over
What's the
4?
tangent of pi over 4?
2.
Oh, that's it.
1.
Yeah.
Yeah.
Good. 1.
Yeah.
Oh, so we just did, okay.
45 and pi over 4 are equivalent. One is in degrees,
45.
one is in radians.
Oh, so the pi over 4 is the angle?
Pi over 4 is an angle. Yes, sir.
The top angle.
Yeah, it's an angle. This is also, you could say pi over 4. But pi over 4 is actually the amount of rotation.
Yeah.
It's the amount of rotation. All right? So that's pi over 4. Good. Now, getting rid of this one. I want to get into this stuff you haven't seen before. How many degrees would be halfway between the 90 and the 180?
139.
135. Yes, picking up on that quick. 135.
Oh, okay.
Right?
So
Don't we
from
agree that
90 to
we
180.
from halfway from 90 to 180 is here. And so we know that this is split into 45s. So 90 and 45 make 135. So 135. How many radians is 135? Yeah? So what are we adding together first?
Pi over 2
And pi over 4. Excellent. So what's half a pi plus a quarter of a pi?
3/4 of
3/4 of a pi.
Yeah, that.
Yeah, that. Okay. 3 pi over 4. 3 pi over 4 is equivalent to 135. I know it's a lot. I know. I feel the energy in the room. And I'm really, really impressed. Keep it going for a little more. Keep it going. So what if we were to say, what's the tangent of 3 pi over 4? Or the tangent of 135? Let's talk about it. Here comes our triangle. Here's our triangle. Where's the angle? Here or here?
There.
This one, right? Because the angle is always what?
Next to
Next to the x-axis. So here's 45, correct? So fill in the triangle. What's this?
1.
1. Okay, now very careful. On the x-axis, we went this way. How much is this?
1.
Negative 1.
Right.
Negative 1.
Huh.
Oh, and I guess so we're still working in graph mode.
Yeah, we're still working in graph mode. It's a trick. Negative 1.
That's all coming together.
Okay. So, what is the tangent of 135 now?
-1.
Negative 1, correct. Because tangent of this angle is opposite over adjacent. I'm writing it. To go. Tangent of 135 equals 1 over negative 1 equals negative 1. And feel free to plug that in the calculator. Right? Tangent 135, and you'll get negative 1. Okay. And now, the whole idea, the last thing we'll do on this front, I'm going to tell you that each quadrant is split into 3 distinct lines. The first line we did, yeah. This one is pi over 4. The next we have is 30 degrees, right here. 30 degrees. And 60 degrees. So 30 degrees. How many pi is that?
20.
So what do you think? So if this is pi over 2,
That's 4.
and this is a third of it,
Pi.
what's a third of half?
Pi over 12.
36.
Pi over 6. Yeah, pi over 6. Pi over 6. Pi over 6 is 30 degrees. Pi over 6 equals 30. Okay, so that's 30, then we did 45, now 60 degrees. If you have half a pizza, how much is 2/3 of that? It's hard. It's a hard question. It's crazy hard. Yeah, we're at pi over 2 is 90, right?
Yeah.
So how much is 60 in terms of
Pi
pi?
over 5. Pi over 3.
Pi over 3. That's 2/3.
Right.
Oh, 2/6. Excuse me.
Did you say 2/3?
Yeah, no, it's 2/6. Yeah, pi over 3. So now, whenever you want to do something, wherever you want to go somewhere, you just say, okay, if they're saying 3 pi over 4, you say, all right, that's pi over 2, and then a quarter. If they said 5 pi over 4, 5 pi over 4 is 1 pi, and then a quarter would be here. All right, that's a great
5
intro.
pi?
5 pi over 4 is pi and a quarter.
Oh, okay.
Pi and a quarter. And you'd be here. Yeah, that's a great intro, you guys. Hey, thank you so much for a wonderful year. Give yourselves a round of applause. Okay. Bye. Yaymath.org.
Woo!